Hello class 11th student. So in this video I'm going to talk about mathematics chapter 3 matrices. Okay, and in this video I'm going to give the introductions about matrices, like definitions of matrix and all the types of matrix like columns, rows, square matrix, principal diagonals, okay, track, unit matrix, upper diagonals, lower diagonals, identity matrix, unit matrix, okay, etc. These are the some introduction we are going to see in this lecture, right? So if you watch this full lecture, I make sure that this video is going to be very helpful for you and this chapter is going to be very easy for you. Okay, I will also give you practice sets, questions, and what about the exercises present in our Telangana State Board exercise in chapter 3. We are going to cover all this one. Okay, so let's just start this one. Okay, so if I ask you what is matrix, okay, if I ask you what is matrix, so let's understand the first what is matrix here. Okay, so what is the proper definitions of matrix? Okay, it isn't given in your textbook also, but I will tell my opinion what is matrix. You will also understand what is matrix. Matrix is nothing, it is just a arrangement of elements means number. Okay, matrix is nothing, it is a arrangement of numbers in a proper manner, that is called as matrix. If you want to write a definition, then you can write an order of arrangements of elements in, you can say, number in proper way that is called matrix. Okay, the arrangement of an order of arrangements of elements, or you can say number, in a proper way, that is called matrix. Okay, now suppose if I give an example of matrix, then suppose this is a 2 4 6, it is a proper way, it is going that side, so this is a proper way of that side. So this, if I put this 2 bracket in this is our matrix. If suppose a number like 3 4 and 6, and this is going to be in this proper manner, if I put like that, then it is our matrix, that is our matrix, right? So let me ask you, how we represent a matrix? What is the symbol of representing the matrix? Matrix is representing by these two symbols, or we can say this small, but actually it is using in determinants, so we cannot use this, but it is also a matrix. It is symbol of it in matrix also, matrix only, but it is using in determinants. So let's see, we use this symbol, this both symbols, to represent the matrix. Okay, now is it clear? When suppose if I write example like 1 2 4 0 0 0, and if I put like that 2, then it is a matrix, it is our matrices, it is our matrices. Suppose if I write this same number like 1 2 4 0 0 0, now can you say this is a matrix? We cannot say this is a matrix. Why? Because there is a nothing symbol to say that it is a matrix. We know that when we put like that, then we can say that this is a matrix. So I hope you will understand what is matrix, how we can justify that this is a matrix or not a matrix. Okay, let me show you some example. Suppose if I ask you, let me ask you like 3 4 0, okay, and if I give you like suppose 204 and 402, if I ask you in this one which is matrix or which is not matrix, so of course this is the option A and this is a B and this is a C, which is matrix. If you know the answer, please comment this answer. So according to me, the matrix is this one, because it have both two close matrix symbols of the bracket. Okay, so that's why it is a matrix. It is a not matrix. Why? Because it is not given that side. Okay, and that's why it is a half. Here it is not given, so we cannot justify it is a matrix. Okay, I hope you will understand how we know that it is a matrix or not matrix. Is it clear? We are not coming in the type of matrix. First we are learning that what is a matrix and how we know that it is a matrix or not. It is clear right now. After that, I am coming to one main point here: row and column. Okay, this is a very interesting, because lots of the student are confusing in this one only. So row and column. Okay, I ask you, row means what? Row is representing by like that. Row is representing by like this. You know ray. How is ray? Ray is like that. So ray means you can understand the row. And column. Column is like a stand. It is a stand. You can say it is a stand. How you climb? We can climb like that. So when they ask you row, you have to remember ray. Ray is like that. Then you have to ray is always like that. And column. Column means we have to remember climb. How we can climb? Just like that. So we have to remember a straight line. And ray means a plain line. Okay, ray means plain line, or column means a straight line. Straight lines we can climb, plain lines we can walk, or ray is in plane, right? Or you can represent as a race. Race is always not going to be in plane only. Race is going, not in the trees and something hillies. Okay, now this is in a stand, right? Is it clear? Right. So one more thing here row and column is clear. If you not understand, then also we can understand the vertically or horizontal. Okay na? Vertical or horizontal. I hope you know. Vertical means I ask you, is vertical or horizontal? Vertical or horizontal. Okay na? Vertical. Row column is vertical. Vertical means column, horizontal means row. Okay na? Always remember. Otherwise we can remember this. Row means ray, which is like that. Column means climbing the tree. It is like that. Is it clear? Right. So let me ask you some question. This is 2, 4, 6, 8. Is it a matrix? Yeah, it is a matrix because both have that sign. Okay, right now I'm asking, which type of matrix is it? Is it our column matrix? How can I say that it is a column matrix? Because it is in the column. No, this is a column. No, this is not a column. This is a ray. This matrix representing that side. It is going that side. It means that this is our row matrix. Okay, and if same number, if I plot like that, 2, 4, 6, 8. Okay, so if I ask you, is this a row matrix? Is it a row matrix? No, it is not a row matrix. This number is coming like that. It is a climbing type. So we can say that it is our column matrix. This is our column matrix and this is a row matrix. Is it clear? The row and column matrix. Is it clear? So you know row means like that and column means like that. Okay, is it clear? Let me I give you some other question to remember this. Suppose this is a A. Okay, this A means nothing, number is there. A is like this, like 1 2 4 3 0 minus 6. I am telling you, write the row and column. Write the row and column. Okay, let's I introduce here. So row means we know, row means like that. In this is going to be like that, Okay, this is our row, so we can write row. Let's write row here. Row is 1 2 4. This is a row. Okay, then what is this? This is also going that side. This means that this is also our row. Okay, so we can write another row here. Okay, this is our another row, like 3 0 minus 6. Is it clear? Right now I'm asking, this is a row like that, which is like that, it is a row. And right now I'm asking that write the column. We have to write a column, right? So see here, the column is climbing. In this, which is climbing? Okay, this 1 and 3 is climbing. How is it? Let's me like column. This one I'm writing column. Okay, this is 1 and 3. Of course we have to always put this. Okay, right, 1 and 3. Is it a column? Right. Why? Because it is in this manner, so we can say it is a column. Okay, what is the another column in this one? Okay, another column. Let me find another column. This 2 and 0 is coming that side, this is going that side. It means that it is our column, so we can write here column 2 and 0. Okay, 2 and 0 is our another column. Then another column, did you see? Yes, this 4 and minus 6 is also our column. How? Because it is going like a climbing of tree. So we can write here 4 and minus 6 also are our column. So did you see the number in this arrangement of the matrix, which is in the proper way, like that? Okay, I have to use another pen here. Okay, I use this one. Okay, so which is this one? This is our row, this is our another row. And which is column here? The another column, this is our column, this is our column, this is our column. Did you understand? Right, let me take another example. You have to understand more better if you take another example. Let's be it is, and this is 1 2 4 and minus 3. I'm telling you, write row first and column. In this one, how many rows is there? Let me verify. This is going that side, this 1 and 2 is going that side. Okay, 4 and 3 also going that side. Then it is a 1 row and this is a 2 row. In this, how many rows? There is a 2 rows. So how much row in this one? This is 2 rows. Okay, how much column in this one? Let me verify. This is going downside. Okay, it means that this is a 1 column, this is going one side, this is going to be down. It means that it is 1, this is 2, this is first one and this is second one. Okay, it means that we have 2 columns. So right now this matrix have 2 rows and 2 columns, so we can represent this 2 cross 2. Okay, how we have to represent? This is row, this is column, so we can represent 2 cross 2. Okay, if you didn't understand this, then leave it, I will explain you later. Okay, first we have to understand these have 2 rows, 2 columns. Is it clear? I hope you will understand. Then tell me, this is suppose C, this is 2 and 4. In this one, is it row? How many column in this one? You are telling that, oh, this is have only 1 column. You can see it have 1 column. Yeah, that's good. This is going that side, it have 1 column. But you have to always remember this number is going to be that side also. So it has 1 row and it has second row. So in this 2 rows and 1 column, let me I ask you some question like 2 4 and 6. In this one, how many rows? This is going that side, so in this one only 1 row. row is only one, but in this one column is this one column, this is going that side, this is also going that side, this is, so this is 1, this is 2, and this is 3 column. How? Let me I explain you here. Let's take another piece. Suppose this is a 2, 4, 6, 3, 2, 5, and this is a closed bracket. It is a bracket, it is a matrix, right? The number which go that side, this also going, this is the our row, this is our row. How much row in this one? This is a 2 row. Okay, the number which is going in downside, this is the one column, I represent column as C, this is a second column, this is a third column. Okay, then how much column it has? It has 3 columns. Okay, did you understand? Row means this column means this and this. Okay, let's take another example. Suppose this is 2 and 4. Okay, I'm asking you in this one how many columns it has. You are telling this is going that side. Okay, 1, this is 2 rows. Okay, it has 2 rows, it means row is 2, but column is coming one side, it means that column is 1. Okay na? Let's take another example like 6, 6, 0. Okay, I have to write something neat and clean. Okay, right, so I am writing here, this is 6, 6, 0. Okay, it is going that side, one column, another column, third column, this one, this one, this one. It means that it has 3 rows. And how many columns? Columns is only one is going here, so 1 column it has. I hope you will understand the rows and columns. Okay na? Right, so let's I give you some questions like this is a x plus 1. Okay, and this is a x square minus 1, this is a 3, this is minus 3, this is 7 plus sine x and 2, this is the 4, and this is a sine x it is. Okay na? And this is a 3 plus sine 2x, and right now it is our matrix. And I am asking to you which is the column here. Column means you understand this, which is in this side. Okay, it is something bigger I think, which is going like that, this is the row like ray, and which is going like that in downside, that is our column. Okay, and in this one never stop, this is a 1 in one column, this is also in 1, this is also 1, this all are. Okay, so don't be confused, this is the x is different, 1 is different, it's not, it is same numbers. Okay, let me explain you here. Suppose let me make something smaller. Okay, so if you see this one, let's see. Okay, so if you see this x plus 1 is going which side? It is going that side. That side means it is a row, so this is our row, this is our row. What is it? This is, okay, let's check out, this is our row here. Okay na? I take another pen here, this is row. Okay, this is our first row, which is, this is our first row. Okay, then you are telling, brother, this is also going that side only. Yeah, that's also going that side. Then what is this? Then this is our second row, this is our second row. Okay, this is our second row. Then after, this number is also going that side, brother, then it is our third row. Did you understand the row? This is our, which is going like that, this is first is going like that, first row, second is going like that, second row, and third is going like that, this is our third row. Is it clear? Right, so let me introduce with column. Okay, let's check this one. The number in this one we have to use something bigger. Okay, the number which is going like that, okay, it is going to vanish this. Okay, so I have to balance this. Okay, right. Okay, right, column, this is clear. Okay, I have to represent this. which is in this one. This is a row, this is a second row, this is a third row. Right now the thing is that column. What is the column? Okay, column is like that. Okay, so this number is, all these numbers are coming in. Okay, right. Okay, this number is coming like that, right? Okay, isko pencil, we have to use the pencil for this. Okay, right. So if you see this, okay, is it right? This number is coming in this, climbing like that. Okay, this is a 1. So this is our first column. This is a column. Why? Because it is like that, that's why. Right now if you see this one, this is our second column. Why? Because it is like that. And this is our third column. Okay, is it clear? This, because this is like that. In this one we see that there's a 3 rows is there and 3 columns is there. 3 rows is there and 3 columns is there. It means that this is, whatever this going this side, this is the rows. Okay, and whatever that's coming downside this, all these are the columns. Is it clear? I hope you don't have any kinds of doubt about the rows and columns. If you don't have any kinds of doubts, just comment this one. Okay, right, you don't have any doubt in rows and columns, right? Is it clear? Right, so I hope this introduction is clear for you. Okay, so right now I'm going to introduce with types of matrix. Okay, so I introduce with types of matrices. Okay, actually in this one we already learned 2 types. That is first our type of matrices in this one, columns matrix and row and column matrix. Okay na, first matrix is this row matrix. Okay, row matrix, and the second is this column matrix. Okay, I write here 2 sides only because you will understand more better it in the front of you. Okay na, column matrix. We know that row is like that, like 2, in this one the comma is not coming, always remember 2 4 6. This is a row matrix. 2 4 6 is in like that, then it is our column matrix. We know that very well. But what is the definitions of row matrix? Okay na, let me introduce the definition of row matrix. Row matrix is here, don't we go through that. Row matrix means, let me introduce here, it has, okay na, row matrix, it has one row, it has only one row. In row matrix it has only one row, it doesn't have 2 rows. If suppose I tell you this 4 6 2, this 3 2 4, this is a not a row matrix. Yeah, I know it is a 1 row and 2, it is a 2 rows. But according to the row matrix, when arrangement have only one matrix, when the arrangement have only one row, suppose this has a I am sorry. Okay, so here you see it has only one row. When you have only one row, that is our row matrix, that is the row matrix. But actually in this, don't be confused, like 2 4 is 6 is given, 3 4 is, it has two column is 2 rows is there. This is row is great, it is a row only, but that's the not row matrix. It is a row but not a row matrix. Row matrix means it has only one row. Row matrix means it has only one row. Like that only column matrix means it has only one column. Okay na, that is the like that. Okay na, this is the like that. Row matrix means single row. Row matrix means single row. Column matrix means it has only one single column. Okay, is it clear? Right, you have to clear this. Don't go through like I'm telling you. You are going to confuse. You are telling this 2 4 6 1 2 4. This is a row. Yeah, that's row. This is also row. This good row. This is column. This is column. This is column. That's right. But you are going to confuse here. This is a row, this is a row. Then why it is not a row matrix and this is a column matrix? We know that if it is 2 4 9, this is our single row matrix. Like 2 1, this is our column matrix. But if it is more than one, suppose if I tell you this is 2 4, this is a column. Okay, this is a column matrix. But if it is 2 4 1 2, it has two columns. It is not a column matrix. Why? Because the rule is that if a row matrix have only one row, that is our row matrix. If it has only one row, a single row, it has row matrix. If it has a single matrix, if it has a single column, then it is our column matrix. Single column matrix. Single row matrix. And don't be confused. If suppose if I tell you, in the case if it is given 2 4 6 4 6 8, if I ask you, is it row matrix? No, it is not a row matrix. Row matrix means it has only one, or you can say single row, but it has two rows. It has two rows, right? So it is not our row matrix. Okay, it has two rows, so it is not our row matrix. Is it our column matrix? No, because it has 1 2 and 3. It has three columns. It has three columns, so it is not our column matrix. Why? Because column matrix need only one column. Okay, right? Is it clear? Okay, I hope row and column matrix is clear for you. Okay, right, till here it is clear. Okay na? And I want to verify this one. Okay, is it clear? Exactly. And I am going to explain one by one here, so don't be confused. Actually, what is this 1 and 1? What is this 1 and 2? What is this 1 and 3? Don't be confused in this one. I will explain. This represent the row, this represent the column. How? I explain you. I know you are going to be confused in this one, so don't be confused. In the next I will explain this one. After that, I tell you our third part, that is the square matrix. This is a very important. Why? Because we are going to learn this one only, a square matrix. Okay, we are going to learn okay, right, matrix. We are going to learn a square matrix. A square matrix, the definition of a square matrix is given in your textbook, is that the matrix which have rows and columns are equal. In a square matrix, we can remember row and columns to be equal. The number of row and the number of column is to be equal. If suppose it has two rows, if it is has two rows, then definitely it has be two rows only. If it has two rows, then definitely it has two columns. If it has two rows and if it has two columns, then and both are equal, then it is our square matrix. Suppose let me tell you, if row is 2, okay, row is 2 and the column is 3, then both are not equal. Rows and columns are not equal, so then we can say this is not a square matrix. Okay na? The requirement of a square matrix is that the number of rows and the number of columns is to be equal. Okay na? Right. So write the definition here. The number of rows and the number of columns is to be equal. What is the definition of a square matrix? The number of, I am writing no, it means number only. The number of rows means like that. Okay na? And columns means like that. We have to remember the symbols. Columns, the number of rows and columns are to be equal. Are to be equal, then it is our square matrix. Okay, right? Is it clear for you? Right. So okay, so I hope you will understand the this definition of this square matrix, and you will also understand this. Okay, so right now I will explain this with the given the examples. Okay, so we already know that the number of rows and the number of columns is equal, then it is called as the square matrix. This is a very important. Okay, now this is a very important. Let me explain you here. Suppose, just take an example. This is a matrix 2 4 3 2. I'm asking you, is it a square matrix? Then how you can say that? Let me see this. How many rows? This is a 1 row, this is a 2 row column, this is a 1 column, this is a 2 column. It means that the row is 2 and the column is also 2. It means that these both are equal, then it is our a square matrix. This is our square matrix here. Okay now, is it clear for you? And we can represent a square matrix m a equals to aij equals to m cross n. Then you are asking that what is this aij? I means row. Okay now, this first means row, j means column. Okay now, j means column, a is nothing, a is a matrix, whatever the given matrix this, and m cross n means it is not going to be multiply. Okay now, always remember, it is not going to be multiply here. Okay, it is not going to be multiply here. Okay, right. So I explain you here how. Let's take an example. This m and cross. So m means, okay, I explain here. M means row, m means row only, m means row, and this is the n, right? N means column. Okay, let's first I explain you row and column, then you will. You see I or j and m cross n. In this one, you are going to see this lots of time. I means row only, I means row, and j means column. Like that only here, m means row, and n means column. Okay now, always remember, I or j means row and column. I means row, j means column. Here m means row and n means column. Always remember, it is also mostly we are going to use mn. Mn means row and column. Okay now, right? Right? Actually, the tongue is slipped here. Okay, suppose let's see. This is a 2 4 3 3 4 6 2 1 0. Okay, right. Okay, so right here I can here. Right now I am asking in this one, how many rows in this one? Let me write. This is a m cross n matrix. M cross n. M cross means this is a row, this is the column. How many rows in this one? Let I write you. This is a 1 2 3. In this one, m means row, we have to write 3 rows, column 1 2 3. In this one, 3 column. It means that how many elements present? It means that this is a 3 cross 3. We can read this cross, we can read cross, we can read this as cross, or we can read this y also. This 3 cross, okay, right, we can say 3 cross 3 or 3 by 3. Mostly we use 3 cross 3. Okay now, so it is our 3 cross 3. It means that the number of rows is 3 and the number of column is also 3. Then it is our square matrix. Don't think square means 2 only. It is going to be always 2 2 2 2. Okay, it is not necessary. A square matrix means it is anything. If it is 4 by 4 matrix, both are equal, rows and columns are equal, then it is our square matrix. Okay, don't be confused. I want to clear here everything. I am going something slow here. Why? Because you will understand more better. That's why. Let me explain you here some question. Like suppose this is a D. Okay, this is question given 1 2 3 and 1 2 3. I'm asking you, is it a square matrix? Let's verify that. The number of rows is 1 2. The number of row is 2. Column 1 2 3. It is as 3 columns. Oh my god, I can see this is a 2 does not equals to 3. Both are not equal. Then it is a not a square matrix. This is a not a square matrix. After that, whatever the rows and columns we are getting, we have to write it down, right? Suppose if I ask you, let's take example 2 4 0 0. Is it a square matrix? Let's count. Okay, right. The number of rows 1 2. 2 rows is there. We have to write first rows. Then column 1 and 2 cross 2 columns. This is a 2 columns. It means that it has 2 by 2 matrix. 2 by 2 or 2 cross 2 matrix. So it is our square matrix. Okay, and in the next whatever we are going to solve the problems, you will understand why I am teaching you this very simply. Why I am explaining you this is a 2 by 2, 2 cross 2. Why we call IJ has a row and column and M across N, because when you go to the next, if your concept, this is a basic concept, if it is clear for you, then this chapter is very easy for you. Okay now, and I make sure this is going to be very helpful for you whenever you are studying in Hyderabad or Telangana. Okay, I have lots of experience about our TS education. In mathematics, lots of students are just they are remembering formulas, remembering the question and answer also in maths only. So math is nothing, it is not like that. Okay na, I will make sure everything is going to be clear for you. Okay, don't worry about it because I'm here to help you. Okay, right, so let's come to the topic here. Again, if I tell you this is a 2 4 2 4, okay, we can say this 2 rows and 2 columns, it is a matrix, right? It is clear. Right now I'm asking this, how many elements in this one, how many elements in this one, in this one how many elements is there? In this there is a total 4 elements. Okay, if they ask you this is given matrix 3 0 4 and 2 0 4, okay, and how many rows? 2 rows is there. How many columns? 1 2 3 column is there. Okay, right. Is it a square matrix? No, it is not a square matrix. Why? Because it is 2 cross 3. It is not equal to each other. Rows does not equals to columns, so it is not a square matrix. But they ask you, is it a square matrix? No, it is not a square matrix. Then how many elements present in this this matrix? How many elements is present in this matrix? How we can say? 2 cross 3. First let's see how many, what is a row and column, arrangement of row and column, 2 rows and 3 columns. Then it is about 6 elements, 1 2 3 4 5 6 elements. Okay, right, take an example 2 4 0 1 2 0 1 2 4. Okay, 1 2 3, it have 3 rows, 1 2 3, it has 3 columns. How many elements it in this matrix? 9 elements. How I can say 3 cross 3? 9. But when they ask you how many elements in that time, then you can multiply, otherwise don't multiply. And this 3 cross 3 means it is not multiplied by this one. Okay now, this is don't multiply this. Okay now, this is a row, this is row, this is column. But if ask you how many elements in this one, how many numbers present in this matrix, so you can count, otherwise just you can multiply this one. Okay na, 3 cross 3 9. But don't think this is a multiply symbol, it is not multiply symbol, it is a cross or by. It is clear? It is clear. I am asking to you, is it clear? Good boy. Okay, if I ask you a simple question, is it a square matrix or not? This is a very important. Okay, is it a square matrix or not? Let me verify. It has 1 row, 1 column, it has 1 by 1 matrix. It is our square matrix. M and N both are 1 and 1, so it means that it is our square matrix. Okay, like that. If I ask you 2 4, is it a square matrix? And in this is 2, this is A, this is B, and this is C. In this both, in this third, in this 3, which is a square matrix? Comment this answer. Okay, comment that. Okay, comment me that which is a square matrix, A, B or C. Let me explain you. You can comment this is good, otherwise I explain. In this there is a 2 rows, 1 column. It is equal? Not. This is not our matrix. 1 row, 1 column only na. It is going to be down only by 2. It is as this 1. It is have 1 and 1 rows. This is our matrix. In this one, let's see this 3 rows, columns, 1 2 3, 3 columns. Okay, it has 2 rows, 2 rows and columns, 3 columns. It is not our matrix, so option B is correct. Okay, is it clear for you? Right, so let's come to the another topic. Okay, square matrix is clear. A square matrix is clear for you. Okay, right now a simple question I'm going to explain. A principal diagonal or diagonal. Okay, suppose example, let's I write here. Don't think it is a principal of your college. Okay na, principal diagonal. This is a very easy. This is a very easy, and it is not going to be used in your chapter also. Actually it is for understanding purpose it is useful, otherwise there is nothing uses of this, but if you understand then it is better for you. If you are preparing for any entrance exam, then it is useful, otherwise it is not useful in TS. Okay na, right? So I will explain you here. Suppose this is a 2. Okay, so let's I explain you. This is a 2, this is 4, this is 0, this is 1 2 0 1 3 4. Okay, so first me tell to me it is a square matrix or not. Okay, m cross n, it means row and column. So let's think. This is a 1 2 3. It means that it has, okay, it has 3 rows, columns 1 2 3. Okay, it has 3 columns. It means that it is our square matrix. Is it clear? Okay, right, so I have to use this one. It is our square matrix. Is it clear? This is our 3 cross 3 matrix. It means that it is our square matrix. Right now, what is the principal diagonal? In a square matrix you have to see always a square matrix. Okay na, in a square matrix this line diagonals, the middle of that, this is the principal diagonal. Okay na, this is the principal diagonal, and when you see that one, that is also a diagonal, right? We can say, sir, this is also diagonal, so that is also principal diagonal. No, this is not principal, it is also principal diagonal, but we can call this off diagonals. Okay na, you are looking that 2 and 4, this 2 and 4 are the principal diagonals. Okay, 2 and 2 4 are the, it is principal diagonal. This is the principal diagonal, or we can also say leading diagonals. Okay na, we can say leading diagonals or principal diagonals. And the diagonals which you see 0 2 1, these diagonals which you see, this is also known as the off diagonal. We can call this off diagonal. Okay now, we call this off diagonal, right? Is it clear? This one called as principal or leading diagonals, and this is called as the off diagonals. Okay na, this is principal, this is principal diagonal, leading diagonal, this is off and diagonals. Okay, is it clear for you? Don't worry, it is not going to come in your exam, but this is important for understanding purpose. Okay, is it clear? Right, come to our track. Okay na, right now it is a which one? Fourth one, then fifth. Okay, fifth is this track is very easy peasy lemon peasy. Okay, this is a very easy. Okay na, track means we can represent the track as TR also. Okay, we represent the track as TR, and we can say TR, represent TR or A means any matrix is there. TR means track, and in this bracket A means there is any matrix will be, any matrices will be there. Okay, let me explain you. First let's see the definition, then we will go there. Okay, come to the topic. Okay, let me, what track means, the sum of the diagonal element, the sum of the diagonal element of a square matrix, of a square matrix. Actually track means that if it is a square matrix is given and you can circle the diagonals and the sum of that diagonals is called as track. For example, if I give you example, then you will understand more better. If you understand more better, then you will write more good answer. And track is represented by TR. We already explained you, and let me explain you again here. It is represented by TR, or okay, right, sorry, take it this one. It is represented by TR, and in this bracket you are seeing this A means any diagonals. Okay, let me explain you. Suppose this A means, okay, we have to find TR. This A is given. Suppose this A is given here. Let me ask 2 4 1 0. Okay, now this is given here. So in this, the diagonal is what? The diagonal is this one only. This is the diagonal. Don't go this 4 and 1 is also diagonal, sir. I have to add this diagonal. Don't add this diagonal. You have to take always principal diagonals. Okay, now this you have to take this diagonals only. This diagonals. What is this diagonals? 2 plus, that's the 0. This is 2. This is a track. Then track, okay, this track of A equals to 2. Is it clear? I hope track is clear. Then let me I give you another question. Suppose A is given here. A is given 2 0 1. Okay, 4 1. Okay, this is minus 1 2, and here 7 6 and 9. Okay, actually this bracket is not being like cool. Okay, is it clear? First of all, we have to see this, is it a square matrix or not. It has 1 2 3. It has 3 rows, columns 1 2 and 3. It has 3 columns. Is it clear? Right, we have to erase this one also. Okay, एक number in here. Okay, that number is vanished only from here. Why is it happen? Okay, right, is it clear? Okay, right now we see this is a square matrix, because this is 3 cross 3 matrix. It is equal, then it means it is a square matrix. In this square matrix only we are getting the diagonals. So let's see the diagonals. This 2, okay, I have to use some other pen. If I didn't use, then it is going to be unused. Okay, this 2 minus 1 and this 9 is our principal diagonals. Okay, we have to write the principal diagonals. This is 2. We have to write the plus. We are finding the track A, so we have to write principal diagonal. First we have to see the square matrix. Is it a square matrix? Yeah, it is a square matrix. Then we have to write the principal diagonals. What is the principal diagonals? This 2 minus 1 9. Now we have to add the principal diagonals. 2 plus, this is minus 1. We have to write minus 1, then plus 9. Okay, right now you have to write 2 plus minus 1 plus 9. This is 2 minus 1 1 plus 9, that is the 10. The principal, the track, okay na, track of A equals to 10. This is the answer. How much easy is it? How much easy is it? You know, if the nursery class student also understands this one, they can solve. The thing is that they have to always remember the counting table and addition, subtraction, multiplication. Then they can also solve. Okay, now this is a matrix is a very easy. If you also study this, you can be 1 hour also. If you study this, you will understand. But the thing is this required more practice. If you didn't practice, actually in matrices, why the matrices is so hard, because it is lots of confusing. You will not understand lots of the track, lots of the same thing. It is coming this one. You are getting confused in matrices. Matrices understanding is not hard. The thing is hard is that the confusing. if you practice this chapter and understand as well as is possible for you, then this chapter is easy. Nothing in this chapter, okay, it is like a sweet poison. Okay, so don't worry, math is very easy. Okay, now if you understand, then it is easy. If you didn't understand, then it is not easy. Again, don't fear with math, I'm always here. If you are a big student in math, then I am for you. Okay na, because I am also big in maths that time, but right now I'm not. Okay na, because maths flow in my blood, right? So let's come to the topic. So track is over, right? Track is over, right? So this means that what means this? It means that a equals to, a means nothing, I and j. Let's see, always we have to see I and j. A means any matrix is there, any square matrix. And okay, let's go down brother. Okay, I means row, j means column, m cross n, m means row, n means column. Is it clear? M means row, n means column. Clear? Come to the topic. No, actually we have to erase this one. Okay, we don't need a scale. Okay, right. Okay, so we have to study right now diagonals matrix. This is our sixth one, I think. Okay, I have to change the pen because okay, we have to study the diagonal matrix. Okay na, diagonal matrix, nothing. This is one of the easy, the principal matrix only. Okay na, not it is a very easy one. Diagonal matrix means what? That principal elements. Okay na, principal we already understand the principal diagonals. Principal diagonals will be anything. Okay na, principal diagonals will be anything. And whatever the non-diagonals, okay na, non-diagonals, whatever the non-diagonals will be, okay, where you are going brother? Non-diagonals will be 0. Let me explain you. Suppose we already know that this 2 4 0 0. Okay, this is something crazy. Okay, let me explain. Suppose this is given 2 4 0 6. In this one, which is principal diagonal? Of course, this 2 4 6 is a principal diagonal. 2 6 is a principal diagonal. That's right. This is a principal diagonal. But diagonals matrix, in the case of diagonal matrix, what will happen? This principal diagonal is 2 6, and whatever the element present in the principal diagonal, again, whatever the element present in this is the diagonal. Okay, and whatever the element, whatever the diagonals, this 0 is also diagonal, and this also is diagonals, that is going to be 0. That is going to be 0. Then that is called as diagonal matrix. Principal diagonals, don't be confused, the between of this number. Okay, like if I tell you 2 4 6 1 2, okay, I say it is not like that. Okay, like 2 4 0 1 2 0 1 4 0. Okay, in this one, what is the diagonal? This one diagonal. This is a principal diagonal. That is only diagonal also. That is only diagonal. But the thing is that whatever the element, like 4 0, this have to be 0. If this 1 and 1 and this 1 and 4, this 4 and this 0 and this 4 is also be 0, then it is diagonal matrix. Like how I will explain you. We know that this 2 0 0 1 and this has also 2 then 0, and here it is also given 0. Then this, if the principal diagonal, okay, whatever the principal diagonal, this is a principal diagonal, this is also diagonal, and it have to be 0. Like here 3 0 there, here is also 3 there, but here is 1, then it is not a diagonal matrix. If it is also going to be 0, that's 0, that's 0, that's 0, that's 0. After the diagonals, whatever the element in this one, it is going to be 0, then this is called as the diagonal matrix. You are getting lots of confusion in diagonal matrix and principal matrix. Don't. This is the principal matrix. If principal matrix in this one and whatever the elements is present in this one, it is going to be 0, then it is a diagonal matrix. For example, let me take another example. 2 0 0 2. Principal diagonal, this one. After that, principal diagonals, everything is 0, right? So it is our diagonal matrix. Suppose, let me tell you example. 2 0 0 4 0 0 0 2 0. Okay, right now you can see this is a principal diagonal 2 4 0. After that, this 0 0 0, but here 2 is not 0, so it means that this is a not a diagonals matrix, but instead of this, like 2 0 0 0 2 0, okay, and 0 0 6 minus 6 is given here. Then this one is a principal diagonal, and whatever the after that principal diagonal is 0 0 0 0 0 0. It means that it is our diagonal matrix. Okay, I hope you will understand the diagonal matrix. Is diagonal matrix will be clear for you? Okay, diagonal matrix is clear for you or not? I hope this diagonal matrix is clear for you. Then let's come to our scalar matrix. Okay, so this scalar matrix is also important. This is, I think, 7th one, you can see. Okay, so this is our scalar matrix. Okay, this is a scalar matrix. So if I ask you what is a scalar matrix, the scalar matrix means the non-diagonals will be 0. It is same. The first rule is it have to be a square matrix. It have to be SQARE. Okay, this is something I written wrong. Okay, pen. It has to be a square matrix. First rule. If you want to see the scalar matrix, the first rule is it have to be a square matrix. It means that the number of rows equals to number of column, then it is a square matrix. The second thing is that the diagonals have to be same. Diagonal will be same. If suppose example, if it is 1 given, then it have to be 1 1 only. If it is 2, then 2 2 only. If it is -3, then it have to be -3 only. So the diagonal have to be same. Okay, the next is that non-diagonals will be 0. The non-diagonals will be 0. Okay, now 0 means laddu. Okay, sunna. Okay, right. So actually we have to always remember this. A scalar matrix means if each non-diagonals elements of a square matrix is 0 and all diagonals elements are equal to each other, or you can say same diagonals, then it is called as the scalar matrix. A scalar matrix means diagonal will be same. Okay, it have to be a square matrix, diagonal will be same, non-diagonals. For example, let me explain you. Suppose this is a 2 0 0 2. It is a square matrix. Yeah, 2 rows 2 columns, 2 rows 2 columns. It is a 2 rows and 2 columns it has. And diagonal is there. Yeah, 2 2 is diagonal is there. Okay, first rule is satisfied. It is a square matrix. It has diagonals. Yeah, it has diagonals. It has same diagonals. Yeah, it has 2 and 2 same diagonals. Third rule is non-diagonals will be 0. And after the non-diagonal, 0 and 0. Yeah, 0 and 0. That means that it is our scalar matrix. Okay, na? It is our scalar matrix. Take another example. Suppose this is 0 0 0 0. Okay, it is a 2 cross 2 matrix, 2 rows 2 columns. This is a diagonal is totally same. It is 0 0. After the non-diagonals is this one and this one is 0. Yeah, 0. It means that it is our scalar matrix. Take another example. Suppose this is a -1 0 0 0 -1. That's the 0 0 0 -1. Okay, diagonal is this. Okay, this is the diagonals is this. First let's say this is a 3 cross 3 matrix. Okay, and diagonals is totally -1 -1 -1. Diagonal is same, and after the non-diagonals, that's the 0 0 0 0 0 0 non-diagonals. These are the zeros. It means that it is our scalar matrix. A scalar matrix, when we say that it is a scalar matrix, the diagonals will be same, like -1 in this one 0 0, in this one 2 2, diagonals will be same, and whatever the non-diagonals, it have to be 0, then we can say that it is a non-diagonals. Okay na? Right. So you I hope you will understand. Then let me explain you. I give you a question to verify this, like 2 0 4 0 2 4. Okay, let me here 2. Okay, let's take 2. Is it a diagonal matrix? First of all, it is not a square matrix. Then how it can be diagonal? It is not a square matrix. So if it is not a square, then it is not diagonal. Let me tell you, this is 0 0 0 1 2 0 0 0 4. Right now, you can say, yeah, it is a square matrix. Yeah, it is a 3 cross 3 square matrix. Diagonal is same. This diagonal is same. No, diagonal is not same. Then it is not our scalar matrix. Okay. Right now, take another example. Suppose this 2 0 4. Okay. 0 2 0. Okay. 0 4 0. Otherwise, let's take it 0 also. And okay, I will explain. Let's take it 0 and this 2. Okay, it is a square matrix. Yeah, 3 cross 3 square matrix is there, and it has also 2 diagonals. Yeah, 2 diagonals, verified. But the non-diagonals is 0. Yeah, 0 0 0. This is also 0 0, but this is not 0. It means that it is not our scalar matrix. When it will be a scalar matrix? When the 2 0 0 0 0 2 0 0 0 2. This is the diagonals. Diagonals is totally same. It is a 3 cross 3 matrix, and non-diagonals, these are the 0. So it is our the scalar matrix, right? I hope you will understand the scalar matrix. The diagonals are same because it is a scalar matrix. Why in this one the diagonals is 2 2? Because it is same, because it is a scalar matrix. In a scalar matrix, diagonal is same, and whatever non-diagonals have to be 0. Okay na? Let's come to the unit matrix. This is very important. Okay na? This is 8-1, I think. Okay, unit, or you can say it also identity matrix. Identity matrix, we can call this unit matrix or identity matrix. It is represented by I. This unit matrix is represented by I. In this chapter, you are going to see this lots of this time of I. I means unit matrix. I means unit matrix. We can call this unit matrix or identity matrix. Okay na? Unit matrix means I. It is represented by I. It is represented by I. Unit matrix represented by I. Okay. Then what is the identity unit matrix? In unit matrix, if a square matrix, the requirement of unit matrix is it have to be a square, and the diagonal have to be only one. Apart from one, no one diagonals we want. After that, it has to be non-diagonals. Non-diagonal will be 0. Let me explain. Suppose this is let me ask you 1 0 0 1. It is our unit matrix. Yeah, diagonal is 1 1 1, diagonal is there. After the non-diagonal 0 0, it means that it is our unit matrix. The diagonal will be always 1. The diagonal which we see, this diagonal which we see, it always have to be 1, and after that the non-diagonal, these all are the elements. After that, it have to be 0. Okay, let me tell you, this 2 0 0 2. Okay, it is our unit matrix. No, it is not our unit matrix. Why? Because it is 2 cross 2 matrix is there, and non-diagonals also is there, but the diagonal is 2. It is diagonal is totally same 2 2. Then it is not a unit matrix. It is our scalar matrix. It is our scalar matrix. If the diagonal is 1 1, then it is unit matrix. Okay, then you have to you have to be a doubt that, let me verify, you have a doubt that you are telling that then this is a 0 1 0 1. Okay, this diagonal is same, this diagonal is 1, then it is also a scalar matrix or unit matrix. If the diagonal is totally same and non-diagonals is 0, then it is a scalar matrix. If the diagonal is 1 and non-diagonals is 0, then it is a unit matrix. So brother, this is a 1 1. The diagonal is 1. It means that it is our unit matrix. Okay, now whenever you get like 0 1 0 1 in mathematics, we directly say this is the unit matrix. We cannot say this is a diagonal matrix. But apart from this, if it is 2 0 0 2 is given, then we can say 2 2 is the we can say that this is our diagonal matrix, we can say. Okay, is it right for you? Whenever you get 1 1, if suppose this is a minus 1 0 and 0 minus 1, you can say also this is 1 1 given this is unit matrix. No, it is not a unit matrix. This is not 1, it is minus 1. This is our scalar matrix. Okay na? Is it clear? If you didn't understand, watch again. Okay, because I know you are the first student here, so you will not going to be understand this. Okay na? So there is also null matrix is there. Null matrix means this is our another one, 9th one. Null matrix means it is totally 0. The square will be 0 totally. This is empty. Null matrix means empty. You can say 0. Whatever the 0, when you get 0, like suppose this is element 0 0 0 0 0 0, it is a square, it is not a square, then you cannot say. But if it is like this, it has 3 cross 3 matrix and it have all the zeros element, then you can say it is a null. You can say null matrix or we can say zero matrix. Okay na? This we can say null matrix or we can say zero matrix. Okay, is it clear? Right now I will provide you 3 questions here and you have to solve this, which is a what is it and what is not. Okay, let me give you. Suppose this is a 0 0 0 and okay, that's a 0 also, that's a 0. Okay, and one more here, 1 0 0 0 1 0 0 0 1. Okay, the second is that let me give you let's say take 2 3. Okay, 3 0 0 3. Okay, and another one question here like 2 1 0 0 0 0. Okay, this is something wrong, I think. Okay, let's say that here again 2 0 1. Sorry, this is 2 0 and 0. Okay, and then after, okay, this is 0 3 0 2, sorry, 0 0 and this is 4. Okay, it is given like that. Okay, I am asking you which type of matrix is it, which type of, this all elements are 0, then it is our null matrix. If all elements are 0, then it is null matrix or you can say zero matrix. In this one, diagonals is totally same. The diagonal is totally 1 1 1. The diagonal is only 1 and whatever null diagonal is 0. It means that this is our unit matrix or you can say identity matrix. Unit matrix or identity same. It is represented by I. If its diagonal is totally 1 1, then it is unit matrix. Here we can say this is a 3 3 is given. Diagonals is same. This diagonal is totally 3 3. Then it is our scalar matrix. Why it is a scalar matrix? Why we cannot say this 1 1 is a scalar matrix? Why? Because when it is 1 1 1, it is unit matrix. Apart from 1, if it is given minus 1 minus 1 minus 1, that the scalar matrix. Already explained you. Here the 3 3 diagonals is same. It is a scalar matrix. Here it is 3 2 4. Diagonals is not same. Diagonal is different. But apart from the diagonals, all the elements is 0. Then it is, we can say it is our diagonals matrix. This is our diagonal matrix. If diagonal is any number is diagonal is given, but apart from the diagonals, no diagonals is 0, then it is diagonal matrix. This is the very confusing things: diagonal, scalar, unit and null matrix. Remember, null matrix will be 0. Unit matrix is diagonal will be 1. And diagonal matrix means diagonal will be anything. 2, 3, 4, 5, 6, anything will be. If you remember this 3, 1, you will always remember scalar matrix. I have to revise this one. Diagonal means the diagonal will be anything. Non-diagonal will be 0. Unit means 1, 1, 1. Diagonal will be 1. Apart from this, 0. Null means everything is 0. Okay. And a scalar, the diagonal will be same. Otherwise, all the number is 0. Okay. I hope you will understand and take the screenshot, or you can write the notes of this one. Okay. This is understanding purpose. Okay. Is it clear? Is it clear for you? Okay. So if it is clear for you, then I will move to the triangular matrix, or upper triangle or lower triangle. Okay, I will tell you just in wait a minute. I can tell you one thing here. Suppose this is matrix, right? This is 0. Okay, take another example. Suppose this is 2, 0, 0, 0, 3, 0, 0, 0, and this is 7. Okay, take 7. Okay, now in this diagonal, apart from this diagonal, you see this one. Okay, we see that part. Okay, we see this part. This part is called as the upper. This part is called as upper diagonal. This part is called as upper diagonal. This part is called as upper upper triangular, we can say, not upper triangular. This part is called as upper triangular, and the part which we see this one side, this is called as lower triangular. This is called as lower triangular. This is only this definition of the triangular matrix. Triangular matrix is nothing. Okay, now the square matrix A is named as a triangular, whether the upper and the lower matrix. Okay, now it is defined as the upper. This is the upper triangular and lower triangular. Okay, now if A square matrix is given, okay, this is not a square matrix. Okay, if it is a square matrix is given 2, 0, 4 and 0. Okay, anything it will be. Okay, now anything number it is given, suppose, then this is a square matrix, right? It is a it is not a square, it is a diagonal matrix, right? And this 4 is known as upper matrix. After the diagonal, when you circle the diagonal, and whatever you getting in the downside, you have to take opposite. It is a upper, and whatever you are getting upper, we have to say lower diagonal. Okay, actually when I study that one, I get also confused. I have doubt. This is teaching wrong. Why? Because this is in lower, this is in lower, this 4 in the lower, then it have to lower diagonal. But in textbook also we can say this 4 is known as upper. Okay, na? And the upper, the 0, it is in upper, it is known as lower. Okay, now opposite we can say 0, 0, 4 is lower diagonals, 0, 0, 0, this one is as upper diagonals. Okay, is it clear? Right. So if you have any doubt in this one, you can comment. Otherwise, I think I know this video is going to be something longer in this one. Okay, now equality of matrix. Okay, now let's understand the equality of matrix. Then I have to then I will stop this here only, and I will make another video about the sum of matrix. Okay, na sum of matrix. Then after our video will be ended here. Okay, na right. Okay, so actually this introduction is lots of big, I think. So in the next video we will continue. Okay, na, because it is something bigger, I think. So we will complete in the next video. Okay, so this is a introduction lecture 1, and we will meet introduction lecture 2. So let's meet on the introduction lecture 2.